I want to thank you for that very kind introduction. I assume, I hope. I suspect that he told you that my name is Jim Sterne. I started a conference about digital marketing analytics in 2002 that's now called the Marketing Evolution Experience. And the audience from that created the Digital Analytics Association. And starting in about 1993, I was interested in the internet and started writing books about it. Online marketing, online advertising, online customer service, and one of my more current books is the Devil's Data Dictionary. So just to set the proper definition of artificial intelligence, it is the fourth cocktail. Now you know what artificial intelligence is. To go deeper, it was time for another book. So, artificial intelligence, practical applications. The reason that I write books is as an excuse to do a deep dive into a subject matter. And I knew nothing about artificial intelligence 3 years ago, and it was time to do some serious research. The result was this book, which I will save you the trouble of reading by presenting to you today what's in it. First of all, it is not this stuff. This is scary. If there are any data scientists in the room, then fine, this is good for you. For the rest of us, it makes no sense. It is a foreign language. But AI has come to the attention of the world now because after 50 years of study, we have enough data, and it requires a lot of data, and we have enough processor power, and we can thank the gaming industry for that. The gaming industry created brand new chips, not central processing units, but graphic processing units, which turned out to be much faster and really good for this artificial intelligence stuff. So what I want to talk about is, what is it, a definition? How does it work without too much math? What's it good at, and how we can use it in marketing? First of all, it is not sentience. It is not Skynet becoming self-aware and taking over the world. Not going to happen. Don't worry about it. It's not going to take your job. It's not going to steal your family. It's okay. It's another tool. But to understand how we got here, I want to go back. How many people here have done some coding, whether it's Java or C or COBOL or Fortran? Yeah, okay, I am that old. So straightforward programming is line by line. What do you want the machine to do? And it executes, and that's great. And then we get to modeling and simple math model, Excel spreadsheet. Here is my budget. What if I add 10%? What if I get another 3% lift? What if I move this money from here to there? Very simple, not really statistics, but modeling. Then we get to statistics and predictive analytics, and that's very complicated and requires people with good math skills to build a complex model and run it to see if it works, and as long as it works, it's useful, and to keep iterating. But AI is different. It creates its own model from the data. It looks at the data and makes a decision about the data, and when it gets new information, it changes its mind. So that's the theme. That's the main point that I'm going to cover today. The thing you need to remember is that this is software that can create its own model and update that model by itself. The first part is just execution. Get it done. Run the program. The second one, exploration. But AI is exploitation. We have enough data, we can exploit it now. The execution side is fine, but you know from programming it's fragile. If you get a semicolon out of place, it's not going to work. And the mathematical model, the Excel spreadsheet is great, but then it just gets too complex, and the statistical models just don't scale. And by scale, I mean the number of variables you can consider are limited. It's a human-based system of creating a model, whereas the AI is going to create its own and doesn't have that kind of limitation. We can use this stuff at every step. So doing reporting on the past, looking at why things happen, figuring out, predictions about what might happen, making suggestions and recommendations on what we should do, given the current state and the goal we want to achieve. How can we get there? Actually take the action and then reiterate on the results. So here's AI. It's an umbrella term. Artificial intelligence covers natural language processing, computer vision, robots and self-driving cars, and machine learning, which is where I'm going to spend most of my time. But it's worth talking about the first three because they will be part of marketing. So just to lay the groundwork. Natural language processing is turning voice into text and text into meaning, so that you can talk to your phone and it can understand you and give you an answer back. So what's this picture about? I'm from Santa Barbara, California, where we had the world's first really nasty oil spill back in the 1960s. So if you are in computer natural language processing, your job is to recognize speech. Or was that recognize beach? So in Santa Barbara, they wrecked a perfectly nice beach, and now you can see where it's a challenge for computers to recognize speech. Vision has the same kind of issues. Is that a cat? Yes. Is that a cat? Well, yes, but actually it's a tiger. Is that a cat? Well, no. So visually, even humans have a problem. Can we build a computer that can recognize objects in motion fast enough to create a self-driving car? It's a challenge, right? Can a human look at this picture and say, oh no, it's not a flying carpet, that's the shadow of a different flag? Just takes a second to see, to understand. This is a rabbit. It's a rabbit. Wait, it's a duck. No, it's a rabbit. The mind has to switch. This is how an analyst would look at this. Is it the X or the Y? Very straightforward. Here we've got an old woman looking down or a young woman looking across. Either that is a giant nose or it's the woman's chin. Takes a second and then you can see both. But it's hard for a computer to understand why this is funny. You want to throw a challenge at a computer? What's the difference? Is it a chihuahua or a muffin? It's a tough call. Hard to tell. But we're using AI and vision for things like facial recognition, starting to use it at airports as your boarding pass, using it to unlock your phone. So there are marketing applications that we can do. And then robots. So robots and self-driving cars, a lot of fun. I'm a big fan of self-driving cars. Cannot happen soon enough. But robots are getting really interesting these days. This is Boston Dynamics. And this guy is pretty impressive. And then he does this. Ready? That is amazing. Okay, let's do that again in slow motion because that's fun. Head over heels, and then a little bit of victory wiggle. Yes! Happy robot, right? Okay, so here's something interesting. That's programmed. That's not machine learning. It is a type of AI that's not machine learning. It knows how high the box is. It knows how bouncy the landing pad is. It knows how thick the air is. It's all programmed in to do exactly that backflip in that place at that time. It hasn't learned anything, and that's a very subtle difference. Machine learning is what marketers are going to be doing a lot of. So I want to talk about the types of machine learning, and this is where we get into the language of how people talk about this stuff. If you talk to a data scientist and you understand these terms, then you won't look like I did 3 years ago and just, I don't know what you're talking about. Now you'll get the chance to have a reasonable conversation because you can talk about supervised, unsupervised, and reinforcement. So, supervised. This is where you know the answer to the question and you're teaching the computer. So, is that a dog? Yes, that's a dog. Is that a cat? No, that is not a cat. Important to tell the difference. Is this your friend? Yes, that's my friend. This other one, no, that's not my friend. Type in the name of my friend, and you're correcting the computer. So you give the system lots of labeled data. All right, I want the computer to recognize a cat. Now, if I have a child this tall, and a cat walks in, and I say, kitty cat, the child goes, kitty. And then another walks in, kitty. And then a dog walks in, kitty. No, that's a dog. Oh, I thought I had that right. And then another dog comes in and says, oh, those are cats, those are dogs. I see the difference. Computer can't do it that well. Computer needs a lot of data. And it's going to look at very specific differences through its software, through its computer vision. So I'm going to label this data. These are cats. Computer says, what do they have in common? Well, they all have these pointy ears. And they all have these eyes that are kind of almond shape, and they're all looking in the same direction. Okay, well, what is that? I have no idea. It doesn't have ears. The eyes are squinty. It's looking in the wrong direction. I don't know if that's a cat. So I have to give the computer lots and lots and lots and lots of cats for it to understand what the difference is and what the commonalities are. So I asked the computer to recognize a wolf. So where do you get labeled data, enough labeled data to give to the computer? You go to Google Images. It's like, these are wolves, these are dogs. See the difference? Computer says, yes, I see. This is a wolf. No. So I know why you think that's a wolf, but actually it's a husky. It's a dog. So here's a whole bunch of huskies and a whole bunch of wolves. Now do you know the difference? It's like, oh, okay. Well, here's a wolf. It's like, it's not a wolf. Why on earth do you think that's a wolf? Well, because every other picture you showed me of a wolf, they were standing in the snow. This one standing in the snow must be a wolf. This is logic and mathematics. It is not reason and common sense. That's the difference. Hang on to that thought, because reason and common sense is why you will still have a job in marketing. So that's supervised. Unsupervised is where I don't know the answer. I'm going to give the computer all of my data and say, tell me something about this information that I didn't know before. And it looks at it and it says, well, online buying goes up when the weather is bad. Yeah, that's true, but it's not very useful. But it is true, so good. Ice cream causes drowning. Wait, what? Yeah, every time ice cream sales go up, drowning goes up. So, oh wait, no, that's correlation, that's not causation. Shoes cause headaches. Now, I know this from personal experience. Every time I wake up in the morning wearing my shoes, horrible headache, horrible headache. So clearly shoes are bad, right? And then there's Nicolas Cage. Clearly the man is a monster, and I've got the data to back it up. Because the number of people who drown by following in a swimming pool correlates directly with the films Nicolas Cage has been in. He should be banned from the screen. So correlation, causation, computer's good at correlation. It doesn't know what causation is. So that's something the human is required to do. Supervised, you know the answer. Unsupervised, you're just looking for a pattern or an anomaly, okay? The next one is reinforcement. This is where there is no final real answer. So is that a cat? That's yes or no. But is this the right message to put in front of that person at this time on that device? Well, it might be better than another one, but there's no absolute correct. So the machine is given control and puts that message in front of that type of person at that time and looks at the results. And if the results are good, it gets a numeric reward, like giving a treat to a dog, and it tries to do it again and again. And when the results start to get bad, it changes its approach. Right? So it's learning by doing. So if I have enough data and a specific goal, and I give the machine some lever, some activator that it can use to impact the environment, it'll look at the results and learn from that. Good judgment comes from experience. Experience comes from bad judgment. This is an important issue when you're starting to use artificial intelligence, because you have a bunch of data and you have an algorithm. The algorithm looks at the data and builds a model, and it says, here's what the results are, or here's what the recommendation is, and it will be wrong. And you will tell it it's wrong, and it will go back and think about it some more and come out with another recommendation. You'll say, yes, that's right. And do that about 1,000,000 times a second, and the machine learns. But that means that at the beginning, it's really stupid. It's not going to do it right. It's like a baby learning to walk. It's going to take one step and fall on its face. Next time, 2 steps. Oh, good job, fall on its face. 3 steps, and then, of course, it's running down the street. So this looks really silly and is a video. Oh, there we go. This looks really silly, but this is Google telling the machine about gravity, telling the machine about A, B, get from point A to point B, and here are some obstacles. And here is the shape of your body. The machine is teaching itself how to walk. So it knows that there's up and down, and it knows that it can fall. It knows that it can run into a wall and fall, and it has to jump higher to get over that wall. If it doesn't jump high enough, it won't make it. And this is how it runs down the street. So if you see me doing this down the street, it's okay, I'm just learning how to walk. So, supervised, unsupervised, reinforcement. Those are the 3 big areas. So I break this down into 3 needs for 3 needs. It needs a lot of data, a specific goal, and some sort of control that it can interact with in order to detect what's the most important information, decide what should be done, and then change its mind based on the results. So it's going to detect which data you give it is the most predictive of a given goal. It is going to provide the weighting for which elements are the most important. It's going to make recommendations and then learn from the results. So here's an example. I want the machine to tell me if it's going to rain. So I give it a ton of information about the weather historically. And it looks at all of this information and it says, well, if the question is, will it rain? It turns out that barometric pressure and temperature are the most important bits. The UV index doesn't matter. Sunrise, sunset, not very important. And in fact, it's the rate of change in pressure that indicates whether it will rain. It learns that itself based on the data. If I apply that to marketing, so here's my fancy new electric car, very expensive, which of this data is valuable? Well, it turns out age and location aren't so important. Income matters a lot. Gender, yeah, that matters. And behavior, what are they clicking on? All of that matters a lot. Now, if I'm selling shoes, different bits of information apply. Doesn't matter what the weather is, or it does matter what the weather is. Doesn't matter about gender or income. Everybody wears shoes. And then it's going to decide which of these bits are important and what should we do about it. So here is my goal. My goal is conversion. Here's the data that I give it. The machine looks at that and says, well, if a person has previously purchased from us, if the person has spent more than 1.5 minutes on that particular item, if that person has a pretty close matching search term, has opted in for email, and has looked at more than 5 pages, and postal code doesn't matter. But if they meet those criteria, we should send them an email for 15% off, and that will ramp up conversion. So we do that. In real life, what do? We send out an email, and we wait 3 or 4 days, maybe a week, to get all the results. We tabulate it up. We spell it out in a spreadsheet, and we go, well, this group responded well, that group did not. So let's go talk to our agency and get them to do some creative. We'll review the creative. We'll reject the creative. They'll give us new creative. And then we'll launch another email 3 weeks later. Machine can do it a little bit faster than that. So it's going to look at the results and say, it turns out that maybe they needed to have spent more than 2 minutes. And maybe they only needed to look at 4 pages. And then it changes its mathematical model of what to do next. And then the third piece is we're going to give it control. This is Archimedes with the, give me a place to stand and a lever long enough and I can move the world. The machine is going to send out the email and look at the results and update itself thousands of times a second. That's where machine learning is really impressive. It's pretty dumb, but it's really fast. So it needs data, a goal, and control in order to detect, decide, and revise. So how does it do this? All right, a little bit of a deep dive. I'm going to explain some terminology, but not too much. But I want to start with big data. Big data is the hype, the last hype before artificial intelligence, right? It's going to solve all of our problems. Well, back when I was doing this stuff, I had demographics, psychographics, some marketplace data. That was it. I could put it into an econometrics model and run it, and that's all I had. Then we got database marketing and customer relationship management and Salesforce automation. And I could use those tools and figure out how that data applies to selling. And then came the internet. When the internet came along, it was over. It was just too much information I couldn't handle. Too much volume, there was too much of it. Too many types of data, variety, and it was coming at me too fast, velocity. So this big data solution was MapReduce, Hadoop clusters. It's going to be able to manage all of this data, which was true. It can handle the data, but it can't do correlations on that many variables until machine learning comes along. Because computers are good at wrangling the data and sorting the data and finding anomalies and that sort of thing. The machine is good at this stuff. And finally, it's powerful enough. So, here's our terms that I'm going to zip through really quick to describe. Decision trees and random forest, support vector machines, neural nets and deep learning, which you've heard of a lot, and ensemble models, which you will be hearing more about. So decision trees, you know what a decision tree is. This is easy, right? You just break up groups into segments, right? Start with gender. Okay, so I'm from California. I know there's more than two. It's all right. And then maybe by age, and then by location, or recency and frequency, or. And by the time you get down to that last little leaf, you've got a pretty interesting target that you can give a special message to for a specific amount of lift. Now, when you get down that far, it's too much for the human to figure out. But it's the most explainable model that artificial intelligence uses. So here's where the humans come into it. You're selling motorcycle insurance. You'd naturally rather talk to men than women. Okay, that's expected. Here's something that if you've been in the motorcycle insurance industry for a long time, you learn by doing, and that is they are a better risk if they park the motorcycle indoors. First of all, they can afford a garage, but second, probably it's a midlife crisis motorcycle instead of a teenager tearing up the neighborhood, right? So, good risk, probably can afford the premium, that's great. But as soon as you add more and more layers of data and try to segment it out further and further, you need machine learning to help you with that. It's too many variables to deal with. Because the machine learning system can get down into the deep depths and say, hey, message A should go to that particular group and message B should go to that particular group, and then we'll get lift from those, right? So testing, stuff's great for testing. We've got two messages here. Buy one, get one free, 2 for the price of 1. Same message, right? But subtly different. And there will be different responses. One of these will win. But the machine can take it further than that and say, well, look, the people who went for A, what did they do next? Well, let's give them 2 landing pages to choose from. And which one did they go to? And what button did they click then? And when we get all the way down there, we can say, oh, here is a leaf of the tree that we can get more lift out of because we can treat that segment differently. Now, computers, they're fast, but they're dumb. They're stupid. Humans are slow, but we're brilliant. We can add and subtract and multiply and divide, nowhere near as fast as a computer. Computer is not going to be very creative. It is not going to come up with, buy one beer for the price of two and receive a second one absolutely free. I want to go to that pub, free beer. So a decision tree, very straightforward, easy to comprehend. But random forest, what's that? A lot of decision trees. Terrific, except that we add the item of randomization in there. Let me explain. Take lots of decision trees, so they're all doing the same kind of calculation, slightly different, because every time you do a decision tree, there's an element of a random number generator to start things off, right? But then we're going to randomize the data and we're going to randomize the attributes. Let me show you what that means. Here's my data set. I have rows of people, and I'm going to take random people, and then I have columns of attributes, and I'm going to take random attributes and build a decision tree. That's one decision tree, and then I'm going to build another one with a different set of data and attributes, and another, and another, and another. And I'm going to take all of these and add them up to the result. This is where more is better. I've got lots of different decision trees, all looking at different data, and if they come to a common conclusion, I can be very confident that it's a good solution, right? So, this multiple decision trees become random forest. Support vector machines, now, you might not come across these a lot, but I just love the visual representation of this stuff. You know, this is a visual analogy of heavy mathematics. So here's my data set, blue and green spots. And I'm supposed to draw a mathematical line to divide them. Pretty easy to do, right? Except that there's two vectors right next to the line, so confidence is not really high. Can I change my mathematical line between these to improve the margins and improve confidence? Yes, I can. Boom. Very straightforward, okay? But what if my data looks like this? That's very confusing. And yes, I can draw a mathematical equation that will divide the blue from the green, but it's a very complex equation, and it's very messy, and confidence is very, very low. But that's because I'm looking at this in 2 dimensions. What if I looked at it in 3 dimensions, and I turned this model on its side, and look at that, I can draw a straight line, right? A straight mathematical line, because I've added a 3rd dimension. 3 dimensions is a limitation that humans have. Computers, they don't care. So if you look at multi-dimensional support vector machine graphics in Google Images, you get all kinds of crazy stuff because we can't even imagine what multiple dimensions looks like. But what that means is the system is really good at segmentation. It can take this messy data and figure out how to slice it by looking at it in multiple dimensions. So that's support vector machines. Neural nets and deep learning is everybody's favorite toy these days. So let me walk through how this works. Let's say we want to go to the movies, right? We have 3 different inputs. What's it going to cost? I want to go to a Hollywood premiere. Get on an airplane, rent a hotel, rent a tux. It's like, ooh, that's too much money. No, we're not going. Okay. How about the weather? Well, it's raining horribly or it's freezing cold. Yeah, we're not going to go outside. Even if it's free, we're not going to go. And then how difficult is it? We have to get a babysitter. We have to make sure dinner is taken care of up front. We've got too many headaches. So we take those 3 inputs. Any one of them can overwhelm the others and decide whether to go to the movies. Now, there's also then these hidden layers of thought process that you don't always talk about out loud. Last time we went to the movies, we saw science fiction, action adventure. That means this time we have to see a romantic comedy. Last time we went, she broke her tooth on a piece of unpopped popcorn. Doesn't have a very happy feeling about it, so she's going to probably decline just because it wasn't a good experience. Or maybe I actually have to go look in on my father who's been in the hospital, and I'm not saying this out loud. This is hidden layers, and the answer is, hey, do you want to go to the movies? Not really. Okay. What's going on in the mind? Well, you could talk it through if you had several hours, but the machine is doing these hidden layers itself, and it's doing a lot of them, right? So you show it a picture, and you say, is this a cat? And it looks at the ears, and it looks at the eyes, and it looks at the fur, and it looks at everything it knows about cats. And it says, yes, that's a cat. And you go, no, that's not a cat. And in fact, what I want you to do is go back through your model and figure out which node had enough weight that it caused you to say yes. Go all the way back through that thing, and that is called back propagation. And I promise I'm not going to show you any more math than that. But this is a way for the machine to correct itself. Back propagation says, oh, that's not the right answer. Let me go back and see what I might have gotten wrong, correct for it, and try again to say, oh yeah, that's not a cat. I got it this time. And these things can be as deep as you need because we have the processing power to do that. So, decision trees, support vector machines, neural nets and deep learning, ensemble models. So ensemble models are fun. Remember all that scary stuff I showed you earlier on? That's where those come in. Because I'm going to take all of these together and I'm going to make the machine responsible for deciding which one of these algorithms is the best one to use and in what combination. When you start layering machine learning on top of machine learning, things get very powerful very quickly. So you're going to hear more about ensemble models every day from now on. Okay, well that's interesting, but what can it do? What's it good at? All right, so a couple of more definitions for you. Dimensionality, cardinality. Dimensionality is how much do we know about something? So low dimensionality, customer, name, address, phone number, recency, frequency, monetary value. We have a handful of things we know. Web analytics, lots of behaviors. So that's a medium amount. But language, thousands of dimensions. Okay, so what is a dimension in language? Well, let's start with cats, as long as I'm still on cats. Here's one dimension. A cat is an animal. It breathes, it reproduces, it has fur, it has a tail, and claws. Well, it's also a pet, a household pet, so like a dog or a bird. So it has attributes that are similar to those that are separate from the fact that it is an animal. And then it's part of language, right? Crazy cat, hip cat. And then it's part of online memes, which has nothing to do with the fact that it's an animal really. It's what's happening online. And then, yes, your cat is trying to kill you. We know this for sure. And it's proof that the cats are proof that the world is not flat. Because if the world were flat, the cats would have knocked everything off by now. Lots of dimensions are required for language. That's dimensionality. Then there's cardinality. How many options per attribute? Really high, phone. 7 billion people, 7 billion phone numbers. Lots of options. But what's your age? Well, 122 is as old as we're getting so far, according to Guinness Book of World Records. And are you alive or dead? Pretty low. There's only a couple and a half choices. You're alive, you're dead, you're Schrodinger's cat. Those are the options. That's it. So, dimensionality, cardinality, machines are really, really good at this stuff. If you have 100,000 customers, but you only know 2 things about them, that's easy. If you have 100,000 customers and you know 100,000 things about them, that becomes impossible for a human. You could take an infinite number of interns and not come to a valid conclusion, right? So, give it to the machine. Now, how is it useful? It's useful for marketing, right? I wrote this book. I said I'd give you practical applications. So let's talk about it. And let's, of course, start with robots. Because if you check into this hotel in Japan, a robot will check you in, take your credit card, and give you your room key. Unless you go to the next counter over, and then this robot will check you into the hotel. And then another robot will bring you a midnight snack. So, okay, Jim, that's hotels. What about marketing? Well, in store, I go into this hardware store, and a robot greets me at the door and says, what are you looking for? Well, I need a new kitchen faucet. Okay, follow me. And it watches behind to make sure that it's not going too fast. It's doing inventory control as it walks along, and it takes you to the kitchen sink faucets and says, here they are. Do you have any other questions? Well, yes, I'm interested in the exact color and how it'll fit with my interior. Oh, just a moment, I'll get a human. So that's in use already. Robots are in these 11 stores in California for testing already. What about computer vision? Here's a company that will look at social media to find your logo or your competitor's logo, and will determine and report back to you who is showing it, what are their demographics, how often are they showing it, what is their sentiment related to it, do you want to get the rights to use that in your advertising, do you want to sell advertising against that social media? So computer vision becomes very helpful for marketing. It's also useful in terms of augmented reality. You know, here are the prices of the shoes on the shelf. Here are specifications. When you look at a flat piece of paper and you put your phone over it, now you've got a whole 3D model of it. Now you've got recipes coming out of the ketchup bottle. And facial recognition we've talked about before. This is Warby Parker looking at your face, take a picture, upload it, and it will recommend what glasses to wear. So if facial recognition is actually coming into its own, it's not too long before we get to billboards that target ads based on the car you're driving or what gender you are, and then it's only a step away from recognizing who you are as an individual. Welcome, John Anderton, right? Now we have the store recognizes you and asks you about previous purchases. If you've not seen the movie Minority Report, you really owe it to yourself to see that. All right, voice recognition, turning voice into text, text into meaning, and answering questions. What happens if we hook this up with lots and lots of data? What do we want? Chatbots. When do we want them? I'm sorry, I didn't understand your question. They're not very good right now. But they're getting better because as we talk to our phones more and more, we're teaching it how we speak. What do we want? Bots. When do we want them? No, we really don't want bots. They're crummy, but they're learning. They're getting better. However, they require lots of data, including your location, location history, contacts, voice input, speech and handwriting patterns, typing history, searching history, calendar details, content and communications history for messages and apps, and other information on your device. I'm thinking, not now. That's a little nerve-wracking to think that Microsoft is going to grab all of that stuff just to answer simple questions. That's a little spooky. But there's some bots that are useful. So here's my credit card company. How much did I spend on Uber in September? How about October? Now, that seems pretty straightforward, but actually, it's very complex because from one question to the next, the computer has to remember that I asked about Uber and I asked about how much money did I spend, and all I said was, how about October? And the ability to see that phrase as relating to the previous question is pretty complex, pretty easy for a human, tough for the machine. X.AI is a intelligence that works through email to schedule meetings. That's all it does, schedule meetings. I want to have lunch with you sometime next week. So I send you an email and I copy Amy at X.AI, and you and Amy have a conversation because Amy's looking at my calendar and Amy knows where our offices are and how long it will take to get there. And on Monday, I don't have enough time between meetings to get to the restaurant, but Tuesday is okay. So you and Amy negotiate, and when you're done, Amy tells me that I now have made an appointment. If you're in marketing, that's kind of interesting. If you're in sales, this is huge because you spend all day scheduling meetings or even just phone calls, right? Lenovo figured out a way to attach voice recognition to their back-end database. And I'll let Ashish from Lenovo tell his story.
A few years ago, we created Lucy Sky. Lucy stands for Lenovo Unified Customer Intelligence, which is our big data analytics platform. Lucy is on the cloud, and hence we call it Lucy Sky. On top of Lucy Sky, we built hundreds of different dashboards. But what we realized was that many of our executives kind of needed information in near real time. They really didn't want to go to a dashboard to get the answer. We used a partner of ours, Blue Ocean Market Intelligence, to actually help us bridge Lucy Sky and Lenovo Smart Assistant. So what that means is our executives can get answers to business questions a lot quicker and make decisions in real time. We could ask questions like, hey Lucy, what's total shipped units this quarter?
The total shipped units this quarter are 248,500 units.
Hey Lucy, what's total shipped revenue this quarter?
The total shipped revenue this quarter is $108,600,000.
Lucy, am I cooler than YY?
No, Ashish, you are probably high on something.
Lucy, what am I high on?
Lucy in the sky with data, and here is a song I recommend.
Yeah, so it gets silly from there. But the real value to Lenovo is not just that the executives feel really cool because they can talk and get answers, but the analysts over in the corner are not interrupted all the time by these random questions. The machine can answer the questions for them. Staples is an office supply company, and they have this easy button that they have then made voice activated. It is, you can tell it you want to place an order and buy blue pens. You can tell it that you need more copy paper. You can text it that you need to buy another ink cartridge. You can take a picture of something that you need, like supplies in the supply cabinet, and it will automatically order for you. That kind of capability of understanding what you want and turning it into a purchase order is pretty amazing. Here's one company that will look at, put out display ads with sequential phone numbers, call now, and that phone number will show up on the landing page. So we know what ad caused that click. But if it turns into a phone call, we also know which ad caused the call and which landing page caused the call. Now, the call center is being helped by an AI system. The AI system says, oh, we recognize who that phone number is, it's a customer, and it sends it to the customer service department instead of sales, and it listens to the call in real time. Yes, I'm having a problem with my keyboard. Oh, well, this is a hardware problem. Yeah, there's a key that's broken. Here are the things that you might say, and here are the frequently asked questions. So the human has the empathy, the human has the relationship, and the machine is providing that next step to make the customer experience so much better. Here's the fun part. If the sales rep or if the customer service person turns it into a sale, or the call went to the sales department and it turns into money, the system is listening to the fact that a sale was made, and it updates the Google AdWords bidding profile to change the bidding in real time. To say, oh look, we put that ad on, it caused a purchase, let's increase the price that we're willing to pay for that ad in real time. That's where it gets fun. Okay, so there's the cheat sheet, right? Here's what you've learned so far. And when you download this presentation, that's the one you can just clip or take a picture of, or you can clip it to the wall. You've got your AI cheat sheet. But gee, what does this mean to me? How can I really use this stuff? So a couple of pointers. Number one, if you're not good at analytics, don't go there yet. You actually do need to have a good understanding of why analytics is valuable in order to fully grasp and fully understand what can happen here. You need clearly identified goals. It's not just make me smarter. It's let's increase email opens, or let's increase click-throughs, or let's increase conversion, something very specific. One of these four would be ideal. Make more, spend less, make customers happy, increase efficiency. But you need to get more specific than that, and even more specific than these marketing goals of raising awareness all the way through loyalty, right? You have to get very specific or the machine will get confused. And boy, you've got to have good data. You have good data, good enough for Google Analytics, that's great, but no, you've really got to have good data. You've got to have definitions that everybody agrees on. You have to have clarity of your data. You have to be confident that your data is going to serve, because you're going to bet the farm on it, right? You've got to be sure it's trustworthy. You're going to stake your reputation on this data. So that's why I recommend a data steward for every data stream, because a lot of data streams are going to come into this stuff. So what should we do first with AI? The stuff that the machine is good at, that usually you give to humans, right? Those repetitive tasks that you think need some kind of common sense. You can't just write a rule. So testing and lead scoring, email routing, simple stuff that you would give an intern, give it to the machine. Should we build this stuff? Should we hire a bunch of data scientists and build this ourselves? I'm going to suggest that's not a good idea. There's a lot of tools out there these days. Oh, you know what? This is 2015. Here's the 2017 version of that, right? There's a lot of tools out there already. So let me give you an example. Harley-Davidson, Albert Einstein come together in the middle of New York City. Harley-Davidson retail store goes out to a startup called Albert Einstein, and says, here's my data, let's go to work. So let's look at social, search, email, and SMS marketing to increase sales in New York City. They found out pretty quickly what messaging works. Call now works better than buy now. What happened? Website visits went up, leads went up, sales went up, dramatic increases once, right? You can take a big leap forward, and then you're back to incremental improvement. Here's another example. This is a lingerie company out of Italy. They asked Albert to look at behavior on their website and identify something they're not taking advantage of. And it turned out maternity lingerie was a big market that they were not taking advantage of. So they put up a specific landing page and a section on their website. They started blasting emails out, and by the end of the week, they had improved the messaging going out, and sales went way up. They then asked Albert to look at lookalikes. Where else can we sell that's going to be familiar? He said, well, Germany. Within 6 months, they were selling half as much in Germany as they were in all of the United States. AI can be incredibly useful. Strongly recommend that you look at the marketplace and buy rather than build your own. You're responsible for what data goes in. Too much data, confidence is low. Too little data, confidence is high, but the answer will be wrong. So what problem is there that we're trying to solve? What data are we going to give the machine? And then there's the smell test. You can look at these right away and go, yeah, that's not going to work. That's just wrong. I understand why it happened, but it's wrong. I can see that defiant Erdogan attacks EU and backs restoring death penalty. That's the wrong picture, right? Iran judiciary detains Rouhani's brother in corruption case. That's the wrong picture. Millions of pounds of hot dogs recalled in the United States after bone pieces found. No. And it's, that's Google. Here we have Amazon saying, hey, let's create products. Here is phone case with this old woman on it. What? Here's a phone case with a pregnant teen on it. Excuse me? And here's the one I'm afraid my brother's going to get me for my birthday. The man with a crutch and the diapers. Like, why would you? And if you don't know about Tay.ai, you should look it up. This is an object lesson. Microsoft fell into this hole badly. Your job then is to hone your domain knowledge, because computers are fast, but they're dumb. Humans are slow, but we are brilliant. The housing crisis in the United States happened because the people who understood the math didn't understand the world. People who understand the world didn't understand the math. Hone your domain knowledge. What you know about marketing is what sets you apart. What you know about the industry that you're doing marketing in, that common sense that you've gained over years of experience, is what's going to make AI not a competitor and a threat, but a very useful tool. And that's the message I wanted to deliver today. It's a valuable tool. You should learn about it. You should take advantage of it. And I thank you very much for your time. Thank you.